Hello there once again, this is Professor Rodan with Topics in Mathematics. This video is about section 8.3, Perimeter and Area. This worksheet, number 7, is going to focus on perimeter, so let's get started. So first of all, you guys know that perimeter is pretty much the total distance around a two-dimensional figure. So let's say you're just walking on this path here. So if you start here and you walk this way and you walk this way, this way and this way, and you end up where you started, what's the total distance around that path or on that path? So that's kind of the idea, but the formal definition in the textbook is that a perimeter is the sum of the lengths of all the sides of the figure. And it doesn't matter what the figure looks like. If it's two-dimensional, you can start in one spot and go all the way around it. Okay? So another way to say that is the total distance around a two-dimensional figure. Okay, so remember, I'm just going to do the odds, and you're responsible for the evens, whether it's in class or at home. So basically, we're just going to be adding up. If I start with the left side and I go up, 10 plus 9.4 plus 6.7 plus 8.8. Okay, we put that in our calculator, and we're going to get 39.9 meters. Okay, so that's just where I started. I started here and I ended there. But you can start somewhere else. Okay. Now, number 2, you could do the same thing, go all the way around. But basically is a formula for rectangles in particular. So if you start with the left, that's a width. And you go up, so that'll be width and length. So this is us going all the way around, walking all the way around. But really, we have two of the same. We have two W's and, we have two lengths and we have two W's here. Okay, so this is sort of a shortcut formula that's optional. But definitely can use it, especially in more application problems. A little bit more advanced problems, that this formula comes in handy. Okay, so let's go to the next page. Number 3. So we have a figure, almost looks like a couple rectangles together. So we're definitely going to go around, but we need to know what this side is and what this side is. So if you know that the total distance from top to bottom is 53, and you know that this portion is 30, okay, so this is 30, that means that this is going to be 53 minus 30, which is going to be 23, okay? Okay, and then if we know that the whole length at the bottom is 100, so the same thing on the top is 100. So this portion right here So the total is 100. You take away the 61 that's right here, and that's going to give you the 39 for this side right here. All right, so that means if we start, let's say if I start at the left with the 30, I'm going to go up. So that's going to be 39 plus 23 plus 61 plus 53 plus 100. Okay, just add those up and you get 306 meters. Okay. So next we have the same concept, but this time instead of being, let's say, a polygon, we're not going to have any edges. We're going to just go around in a circle, walking around in a circular fashion. So anytime you have a circle, it's the same concept. You start in one spot and you walk all the way around until you get to the same spot we left, and that is, in this case, circumference. So circumference and perimeter, they basically accomplish the same goal, the total distance around a two-dimensional object, but in this case, we're not going to hit any edges or corners, and this is a perfect circle with a diameter that goes a line, the distance across the center. Okay, so this will be the diameter, and then half of that, this part right here, that's going to be the radius. Okay. All right, so we have basically one main formula, which is that the circumference is going to be pi, the constant pi, which in this case we're going to use 3.14, and it actually keeps going forever, but we're just going to round it to the hundredths place. 3.14 is the approximation for pi, and we're going to multiply that by the diameter. Okay? Now this formula comes from the constant pi, okay, which is discovered many years ago, where any circle, doesn't matter how big or small, you can take a quarter if you want, or a clock or whatever, the distance around that object, the circumference, if you divide it by the diameter, you're always going to get 3.14. So that is our constant. And so we rearrange that and we get this formula here. But we also know from diameter that diameter is actually equal to 2 radii. Okay, the radius here is from the center to the edge, and the diameter obviously is 2 of those. So you double the radius. So we can actually rewrite this and replace the diameter with 2r, so it would be 2 pi r. Okay, so either one of those would work. Okay, and so this depends what you get. So number 5, I'm just going to go ahead and do number 5 and 6. Okay, so number 5, d equals 1. So I'm just going to use this formula. And then pi is just 3.14, so this is centimeters. And then number 6, the radius is 1, then going to be times 1 there. So 2 times 1 is 2, so we're going to have 2 times 3.14, which is going to be 6.28 centimeters. Okay, so it just depends on what you're given. Depends on what version of the formula you want to use, okay? To make it easier. All right, so let's go to the next page. yeah, I'm not sure what happened to my picture here, but this is not supposed to be here on my video. So we're just finding the total distance around. So if I start here and I go up and then I come back. Okay, so we're definitely going to have 30, but we need to add 30 plus this. Well, that looks like half of a circle. So we know that the whole circle, we know the formula for a whole circle. So we have the whole circle, which we know is pi times diameter, and that's going to be 3.14 times the diameter, which is all the way across, that's 30. Okay, and then notice that it says, I'm sorry, I didn't mean to do that. We can't round this because it's going to mess up our answer. We got to leave it as pi. And we need to use the pi key on your calculator. Okay? That means it's not going to round it to 3.14. It's going to use more digits of accuracy. So this answer is going to be more accurate. And so you want to leave this answer in your calculator. It's 94.24. And if you don't leave it in your calculator, then you're going to have to round it an extra digit. Okay, and usually that helps out. So even though we only need this many digits, if you want to write something down, you have to do an extra digit there. But I would just leave the big answer. Hold on. So leave on calculator screen. And then you have that sitting there on your screen, and then we want the half circle. Okay, so we're gonna have to cut it in half. So that's gonna be basically so we'll divide it by 2. And that's going to give us 47.12. Okay, 47.12. If you round it too early, you're going to get 47.13. Okay, which is going to be incorrect. All right, so we have the half circle. We have the distance right here. But we need to add the 30 to this. So we're going to add the 30. And that's what? 77.12. Okay. And so in number 10, you're going to do the same thing, but you have a couple extra sides to add to the perimeter. Okay, let's go to the next page, and we're going to deal with this big guy. Okay, and most likely this is going to be on a video check, so make sure you write exactly what I write as far as the work is concerned, right over here. Okay, so all right, this looks complicated, but it's not actually. Okay, if you can imagine So this is a half circle. So these two half circles right here, they actually make a whole. When you have two halves, they make a whole. So if you can imagine them together as one circle, then we don't need to do a formula for a half circle. We don't have to cut it in half because we have the whole circle right there at the top. So I'm gonna call that the big circle. So first of all, this is our basis, pi times diameter, and we're going to use that for the big circle. Okay, we don't have to cut it in half because we have two halves that make a whole. And then we can see the two smaller circles. If you put those together, you also get a whole circle. So if we add those two perimeters, two circumferences of these circles together, the big circle and the small circle, that means the big circle is going to be pi times the diameter of the big circle, as you can see all the way across right here, that's 16. Pi times diameter plus pi times the diameter of the small circle. And you can see the small circle, this is 8. Okay? And actually we could put those together and make 8 plus, they're both pi's, so put them together, we get a total of 24 pi. And we put that in the calculator, or you can put this in your calculator, it doesn't matter. And we're going to get 75.40. Okay, using the key. Don't use the calculator key. Don't use 3.14 to estimate it because you might get a slightly different answer. Okay, so that is it for worksheet number 7. Let's go ahead and go to worksheet number 8. Okay, so now we're on worksheet number 8. And here we're going to do area. So we have the area formulas for different shapes that we've studied before. And so I'm going to draw the picture and then the formula, okay? So the triangle like that is going to have a height. How high is this triangle? So if it's standing up, let's say we call it height. Okay, how tall is it? And then the base, which is this part right here. Okay, that's all you need, but that's actually half of a rectangle. Okay, a triangle is half of a rectangle. Okay, so the area of a rectangle is, we know that it's base times height, or length times width, same thing, but it's half of that. Okay, so it's, a triangle would be half of that, so that's why we divided by 2. Okay, then we go to the parallelogram. And this also has a height. How high is this standing? And it has a base. It doesn't have to be in the bottom, it could be on the top. It's just, I mean, those are opposite sides are congruent anyways. But this one is just going to be the full the full area. We're not going to cut it in half. So this is going to be base times height. There's not much room here to write, so We're gonna have to spread these out some. So next will be the rectangle. The rectangle is basically the same thing, except this one's already right side up. The side is already telling you how high it is, so we're not going to call that height. We're going to call it the width. And this right here is going to be the length. So area is going to be length times width. Okay, so same concept. But slightly different formula, okay? Now the square, if you think about length times width, but everything is the same right here. So we can call that, if you know one side, you know all of them, because they're all the same. So the area of a square is going to be basically length times width, or base times height, which is side times side. And we can summarize that into side squared. Okay, you can use side squared. And then the trapezoid, you can look at the explanation on page 459, figure 8.31. I really don't like that figure, so here's my attempt to explain where this formula comes from. Okay, so the formula for a trapezoid. So I'm going to first draw a parallelogram. Okay, and we already know that the parallelogram is base times height. But this time I'm going to put a capital B. Okay, and you'll see why in a second. So that's not a trapezoid. Trapezoid, well, I can get one if I cut this in half. Okay, so if I make the height right in the middle, okay, what is the base? Well, the base, I just cut this base into two. Okay, so if you notice that the bottom of this trapezoid right here, see, there's my trapezoid. So the bottom, yeah, that's my, let's say, my first base. But if you notice that the parallelogram has another part of the base, which we're going to call base 2. Okay, so the whole base, the capital B, is made up of two bases, base 1 and base 2. So this right here, this right here is made up of two bases, base 1 plus base 2. Okay? So, great. If we use this, that's two trapezoids. Okay, so there is one trapezoid here, and here's the second trapezoid. Okay, but we don't want two trapezoids, we want one trapezoid. So that we're going to replace that B with B1 plus B2. Okay, and if you notice the trapezoid, these are exactly the same trapezoids. Okay, so this B2 is actually right up there. It's the same thing. Okay, so this is why we add the bottom base, the top base. Doesn't really make sense that there's two bases, but I'm trying to explain where the two bases coming from. So this gives us the whole parallelogram, which is two trapezoids. So we need to cut this in half. We only want half of the parallelogram. So we're gonna cut this in half over here, and there is my formula for one of the trapezoids, not both. Okay, so it's b1 plus b2 times the height divided by 2. Like I said, I think this is better explanation than the one from the book. You can look at that one as well. So anyways, that's where the formula comes from. Okay, if you were ever curious as to why there are two bases. All right, let's move on to circles. And we already talked about radius, diameter, pi, and circumference. So let's just go ahead and go to area. Okay, so the area is not, so don't confuse this with perimeter, which is around the circle. Area is going to be like you're painting it. Okay, so perimeter would be like the fence, and then of a yard, and then the area would be like the grass, the land. Okay, all right, so this one simply area equals pi times the radius squared. Okay, all right, so now let's go apply these on the next page. And like I said, I'm just going to do the left side, except for this one. I'm going to do number 8 because I already did a circle, so I don't want to do 2 of them. Actually, there's 2 squares. That's fine. Okay. So this is going to go kind of fast, so just bear with me here. All right, so we know that the area is this formula. We don't have the radius, so we have to cut this in half, which is 2.5, just divided by 2. So this is going to be pi times 2.5 squared. You can just type that all in your calculator. If you want to see more of that, it's going to be 6.25. Okay. And in the end, that's going to be 19.63 centimeters squared. Okay. Now you could do length times width here, but really this is a square, so we can do side squared. So that's 10 squared, which is 100 centimeters squared. Okay, so this is a trapezoid, and not sure what this is all about, but we don't need all that. We need bottom base, top base, add those up to get the total base, times it by the height, and then cut it in half so we get a trapezoid. All right, so we need 8 plus 12 times the height, which is 6, and then divided by 2. That's about 120 divided by 2, which is 60 centimeters squared. Okay, and we have another circle here, but this time we do have the radius, so that's going to be pi r squared, which is going to be pi times 3 squared, which is 9 pi. All right, that's exact. And then if you want the approximation, it's going to be 28.27 centimeters squared. Okay, last but not least, we have another trapezoid. And base, so 8 plus 5 times the height, cut that in half. So that's going to be 13 times 4 divided by 2, so that's going to be 26 centimeters squared. Alright, so those are some applications of simple formulas, and now let's do a little bit more application with more complex figures. Okay, so we're finding the area of this combination of two shapes. We have a semicircle on the top, and we have a triangle on the bottom. So we want to find out what this area is and this area here, okay? To get the total area of the region. Okay, so here this is 6, so there's the R is half of that, which is 3 inches. Okay, so what we're going to do is half of a circle, or a semicircle, so yes, it's pi r squared, that's the whole circle, but we need half of that. So it's going to be pi times the radius, which is 3 squared, divided by 2. And that ends up being 14.14. Okay, then we have the area of the triangle. Which we know is base times height divided by 2. So the base is the circumference there of that circle, half circle, so it's going to be 6 times the height, which is 4. Divide that by 2, because it's half of a parallelogram, or a rectangle, either one. And we get 12 exactly. So the area of the region we need to add those up to get the region. So 14.14 plus 12.00, that's going to be 26.14 inches squared. Okay. All right. So just to give you a little clue about number 12, I'm not going to do it, but I can guide you here. So we have two identical triangles. Remember that the area of a triangle is half of a rectangle or parallelogram. So basically, if you have, these are two triangles, this right here is going to make a whole rectangle. So that kind of saves us from doing two triangle formulas. We can just do one big shape, which would be the whole rectangle. So we have this in the middle that we got to do. That's our big rectangle. And we need to add the whole rectangle that we're putting together from the two triangles. Okay, so both of those are going to be base times height plus base times height. All right, let's see how you do with that one. That's one way to do that. All right, let's take a look at number 13. Okay, so number 13 is once again another region or shaded area. So as you can see, we have 3 circles here. We have the big circle, and then we have 2 identical small circles. Now, the black region that's shaded there, basically, if we just get the big circle, the area of the big circle, and we subtract both of the two of the small circles, so we can just do one small circle and then multiply by 2. Okay, so we know area equals pi times radius squared, so this is pi times radius squared minus 2 times pi times radius squared of the smaller circle. Okay, so we're going to do pi times, so the big circle has a radius of 4. That's the big circle, okay? Look at the big circle. It's from the center to the edge. This is R for the big circle. So this is going to be 4 squared. And then the small circle, the radius of the small circle is from the middle to the edge, and that's half of 4, so that's going to be 2. Sorry. So this is going to be 2 squared. So if we put this together, we're going to get 16 pi minus 2 squared is 4. 4 times 2 is 8, so it's 8 pi. So technically we could put this together to get 8 pi. 16 minus 8 is 8, so this is 8 pi. So like combine like terms, for example, 16x minus 8x equals 8x. And we put this in our calculator, and that's going to give us 25.13 centimeters squared. Okay, so you'll be trying these on your own and with your group, so we will talk about those in class, and let me know if you have any questions, and we will see you in the next video.